Let's be real, AI is absolutely everywhere now. It's in our phones, it's on the websites we shop on, but you know what? It's not magic. And today, we're going to pull back the curtain and see exactly how developers are building the AI features that we use every single day. I mean, think about it. You see all these smart little features pop up and they just work. But have you ever stopped to wonder what's actually happening behind the scenes? How does a software engineer go from a blank screen to an intelligent feature that genuinely helps you out? Well, that's exactly what we're going to dive into. Okay, here's a perfect example we've all seen. You're on Amazon, right? You're looking at a product with thousands of reviews. Who has time for that? Well, instead of scrolling forever, you get this super neat AI-generated summary right at the top. This isn't just a gimmick. It literally saves you time and helps you decide what to buy. It's a really smart, practical use of AI. Or what about this one? You're scrolling through X, you see a post in a language you don't understand. You hit that Translate Post button, and boom, instant English. What's happening there is an AI model is figuring out the original language and spitting out a translation on the fly. And this kind of feature, it's becoming totally standard everywhere. All right, so we have seen what these things do. Now for the fun part, let's get into the how. What's the engine that's actually powering all of this? Well, it turns out it all comes down to one single core technology. And at the heart of it all is the large language model, or what you'll always hear called an LLM. We're talking about the big names here, like OpenAI's GPT or Google's Gemini. They're called large for a reason. They've been trained on just an insane amount of text. They've basically read a huge chunk of the internet, and by doing that, they've learned all the patterns of how we talk: grammar, facts, even sarcasm. You know, probably the best way to think about an LLM is that it doesn't really think. It's not looking up answers in some giant encyclopedia. It's just making a really, really educated guess about what word should come next based on all the patterns it's learned. It's just like the autocomplete on your phone, but, on steroids. And this leads to maybe the most important rule of AI. These models don't have beliefs or true intelligence. They're just incredible pattern matchers. And that means the quality of the data they were trained on is absolutely everything. It's the classic saying, garbage in, garbage out. If you train a model on junk, you're going to get junk back. Simple as that. So, developers have this incredibly powerful engine. But you can't just turn it on and hope for the best, right? You need a steering wheel, pedals, a dashboard. And that's exactly what developers have. A whole toolkit of controls to fine-tune exactly how this engine behaves. So the first thing a developer has to get their head around is this concept of tokens. You see, an LLM doesn't actually see words like we do. It breaks everything down into these little pieces called tokens. A token might be a full word or just part of one, or even a punctuation mark. And this is so fundamental because tokens are basically the currency of AI. They determine everything from the cost to the model's memory. And why should you care about tokens? Well, it all comes down to money. I mean, just look at this. To get 1,000,000 tokens of text out of a model like GPT-4o Mini, it costs about 60 cents. To get the same amount from its more powerful big brother, $8. That is a huge difference. So for a developer building a real product, choosing the right model isn't just a technical choice. It's a massive business decision. Tokens also control what's called the context window, which is really just the model's short-term memory. It's the total number of tokens, everything you've said to it plus everything it said back, that it can remember at one time. If your conversation gets too long when you go over that limit, it literally starts forgetting what you talked about at the beginning. Now, this is one of my favorite controls. It's a setting called temperature, and you can think of it as a creativity knob. If you turn the temperature down low, say to 0.2, the model gets super precise and factual, perfect for summarizing an article. But if you crank that dial up to 0.8, it gets way more creative and expressive, which is awesome for brainstorming marketing slogans. The point is, developers can dial in the exact behavior they need for the job. Okay, so we've got the engine, the LLM. We've got the controls, like tokens and temperature. Now, let's put it all together. How does an app on your phone actually talk to one of these things? It's basically a 5-step dance. Step 1, you tap a button in the app. The app then sends your request to the company's own server. That server then takes your request, packages it up nicely, and sends it over to the LLM. The LLM does its thing, sends a response back to the server, and then finally, the server sends that clean, finished result back to your phone. So you see, the LLM isn't the whole app, it's like a super smart specialist that the app calls when it needs a specific job done. Now, when you see that flow, it might be easy to think, oh, so it's all about writing a clever prompt. But building a real professional-grade AI feature, that's about so much more. That's where solid software engineering comes into play.
Yeah, and this really gets to the heart of it. This isn't one of those flashy YouTube videos about building a whole app with AI in an hour. We're talking about building robust, reliable features the right way, using proven engineering principles to make something that actually works and won't break down the line.
And this brings up a really key distinction. You have machine learning engineers. These are the folks with heavy-duty math and research backgrounds who actually build these giant LLMs from scratch. But then you have AI engineers, and their job is to take those amazing pre-trained models and figure out how to weave them into real applications that people can actually use. That's what we're talking about today. Honestly, the absolute best analogy for an LLM is a database. As a software engineer, you don't need to understand the complex physics of how a hard drive works. You just need to know how to ask the database for the right information. And it's the exact same mindset with AI. You don't need to be a math genius, you just need to learn how to use the tool effectively. So let's wrap this all up. What does this all mean for the future of building software? Well, it means the game is changing, and we're looking at a brand new, absolutely fundamental skill. And this is the bottom line. Pretty soon, every single software engineer is going to be expected to know how to work with AI models. It's not going to be some niche specialty anymore. Just like every developer today is expected to know how to use a database, the next generation will be expected to know how to work with AI. So there you have it. We've pulled back the curtain, and you can see the building blocks, the engine, the controls, the connections. It's not magic. It's just engineering. So that really only leaves one question. Now that you know how the pieces fit together, what would you build first?